Hey guys, so this video is going to be looking at something around atomic structure. It has massive overlaps between A-level physics and A-level chemistry. Now, if you think about the structure of an atom, quite often at GCSE, it's drawn with its nucleus like so, and we use what is called a concentric model. So you draw rings basically around the nucleus. You know you've got your protons and your neutrons in here, and the electrons orbit it, a bit like what they thought the solar system looked like at one point. Now, just like the solar system, that model isn't completely correct. We use this as a baseline model to start explanations, because if you show this to everyone too early, people get confused and people don't like it. So what I want to show you here is something that you've probably seen other students do, and you've possibly, without really acknowledging it, thought that doesn't look right. So let's look at the element lithium. Now, lithium has an atomic number of 3 and a mass number of 7. There are GCSE numbers. So if we remember our pen, protons, electrons and neutrons, we know it has 3 protons based on its atomic number. In an atom, the number of electrons is equal to the number of protons, so there's our number 3. And if we do the mass number, which is protons plus neutrons, we get a number of neutrons as 4. Okay, so if I was going to draw this out as a dot and cross diagram, or just the crosses to begin with, there's my nucleus. In here I've got 3 protons, and I've squashed that in there a little bit, and I've got 4 neutrons. Okay, so that's in there. I would then do, based on my rules of the shells, 2 electrons in that shell there and 1 electron there. Now, some people might look at that and say that's not right. The reason why it's not right, because all the electrons are together, and negative and a negative in terms of charges repel. So you should draw them all spaced out. However, what we've discovered, and it's actually one of the most remarkable things I've learned in recent years, is that actually when something has a certain amount of kinetic energy, one thing we can't predict is the shape in which it will move in. What we have discovered is that even within this, there is a certain pattern which electrons move in. And it introduces us to 3 words. The word orbital, subshell, and then energy level, which I'm just going to put in brackets here as a shell. So the word that we're all familiar with from GCSE is this word here, shell. We know the first shell can hold 2 electrons, the second can hold 8. At GCSE, we tell you the third shell can hold 8, and the maximum electrons we'll put in the fourth is 2. That gives you 20 electrons, which is calcium. Now, at A level, we're going to introduce this idea. So the first thing we're going to talk about is an orbital. Now, an orbital is described as an area of probability. And this is the starting of all of these definitions of finding electrons of opposing spin. Okay, opposing spin. Now, what we've discovered is in the first shell, there's a movement pattern. Imagine a football shape. And remember this ideology here about electrons repelling. If this is a football shape, if we've got 1 electron, let's say moving that way, the other electron in this area, in this football, has to be moving in the opposite direction. Now, the issue that we face here is that electrons are so small. I mean, atoms are so small. Atoms are so small that actually nobody's ever taken a picture of one. We know it's there. We've tested it. We've detected it. So if we've never been able to photograph an atom, how can we expect to show somebody an electron? Again, we know they're there. We can fire them by generating them. What we can't do is stop one and say where it is. And that's the issue. What we do know is that in that first shell, there is this football shape, and we call it an area of electron density. Okay, so these are very specific areas, and in that first shell, yes, it's only got one orbital. Each orbital can hold a maximum of 2 electrons. Now what that allows us to do then is say, okay, somewhere within that first shell, there is this area where we're likely to find 2 electrons. And if one electron's moving one way, the other one's likely to move the other way. And that's because they are really, really small. So that ticks off the word orbital. Okay? We're now going to deal with this word subshell. Now the word subshell comes into play because not all shells have a single orbital. So the first shell has only got one orbital, and it has a very specific name. It's called an s orbital. The second shell is made up of an s orbital, but also a p subshell. Now, how do we separate this word from this word? So, a subshell is defined as this. It's an area of probability of finding electrons of the same energy. Okay? Now, that's really, really important, because if we have a look at the p subshell, it's made up of 3 orbitals, and this isn't the shape of it. If one orbital can hold 2 electrons, if one's moving that way, the other one's got to be moving in the opposite direction. Now, if that one can hold 2, that one can hold 2, that one can also hold 2. So in total, this can hold 6 electrons. If we go back to our first statement here, if the second shell has an s orbital which holds 2, and the p subshell holds 6, these two added together gives you your GCSE number of 8. Alright guys, and I'm going to break it there because there's quite a lot of information to take in. Alright, we'll be expanding this idea in the next video.